For example 3, we're looking at a couple different things. Again, they're not telling us what type of particle, but they're giving us the mass of the particle. So the mass of this particle is 9.30 times 10 to the negative 25 kilograms. Unknown charge, negative, passes through a perpendicular magnetic field of strength 0.255 Tesla and is deflected through a curve with a radius of 65 centimeters. Now I'm going to change that to meters right off the bat, just so that we're working with the proper unit system right away. If the speed of the particle is 3.70 times 10 to the 5 meters per second, what we want to do is we want to find out the number of electrons. And you're going to see this come up again in lesson 2. To find number of electrons, the first thing you need to do is find charge. So those two run hand in hand. If you're going to find the number of electrons, the first thing you got to do is find total charge, then divide by what the elementary charge is to find out how many excess electrons it carries. So those two are always directly related to each other. You know the number of electrons, you know the charge. If you know the charge, you can find the number of electrons. Since this is passing through a curve, we start with then magnetic force equal to centripetal force. Magnetic force again, QVB. Centripetal force off your data sheet can be written as mv squared over r. Since we're looking for Q, we have velocity common on both sides of the equation. So the first thing we could do is divide out a velocity. Q then will be equal to mv divided by br. We have the mass, we have the velocity, we have the magnetic field strength, we have the radius. So this is actually pretty quick. Put the numbers in. 9.30 times 10 to the negative 25 kilograms. Velocity 3.70 times 10 to the 5 meters per second. Watch that when you're dividing, you make sure you divide by the product of these two numbers on the bottom. 0.255 Tesla times the radius 0.650 meters. So I'm going to punch that in on my calculator, see what we get. 9.3 to the exponent negative 25 times 3.7 to the exponent 5. Enter, divide, bracket, 0.255 times 0.650. One thing I always see that happens on diploma tests or unit tests is if you're given numbers that may not be in the right unit system, sometimes students forget the unit systems and then they get a wrong answer as a result. The charge should work out in this case to be 2.08 times 10 to the negative 18 coulombs. And then if you want to find the number of electrons, then it's going to be equal to 2.08 times 10 to the negative 18 coulombs times 1 electron over the conversion 1.60 times 10 to the negative 19 coulombs. Or what some students just realize is to change from coulombs to electrons, you divide by 1.60. You want to go the other way, you multiply by 1.60 times 10 to the negative 19. Notice my coulomb units divide out, and I should be left with a number that should be very close to a whole number. It may not be exact, but you should get some number. In this case, I get 12.97. Remember that there's no division of electrons. There's no such thing as a partial electron. So it'll either be 12 electrons or 13. And that's why a really good indicator in here is, notice it's 12.975 while it rounds to 3 sig digs to 13.0. So this would make sense. If you saw a number like 12.51, you might be a little bit suspicious of your calculation or your setup of your formulas. Should be a number very close to a whole number. That's a good indicator that you've done this question correctly.